Hello everyone, this is KP the Math G here. Hoping that you're having a really great day today. We're going to do some calculus. How about that? Now, whether you be a teacher or a student, I think either way you're going to benefit from this lesson. It is a practice of derivatives. That's really all it is. So if you can look at this and interpret what this is saying here, and then take these questions one at a time and come up with an equation or whatever they ask for, then you've got this. And really, this is one of the easier ones that I found when I would do this. This was not too bad. You just have to be aware of what you are doing and just do that. It's going to be all right. It's going to be fine. Well, let's start with this. This is a 2016 question, free response question, question number 6. And the table here is as follows. X could be 1 or 2 or 3 or 6. F at x is negative 6, 2, 8, 4. F prime at x, that's the derivative of f, is 3, negative 2, 7, and 5. So in other words, let's just say we're looking for f prime at 2. So here's x being 2. F prime at 2 is negative 2. Okay? If I wanted to know what F at 6 is, well, F at 6 is 4. See that? If I want to know what G at 3 is, well, I'm looking at 3 here. G at 3 is 6. Just follow the row and the column there. G prime at, say, 1 is 8. And so on. G prime at 1 is 8. Alright, with that in mind, let's look at the problem. Let K at x be equal to F at G at x. Okay. So, in this particular case, we've got a composite function. Alright? Write an equation of the line tangent to the graph of K at x equals 3. So we know what x we're choosing, and then from there we'll see what we can come up with. Now, I want to find F prime or K prime at x. Let's move up here. I think I can put it in this little corner. K prime at x. Alright, now, why do I want to find K prime at x? Because I'm writing an equation. I need to get the point. X is already 3. I need the y value, okay? And then I need a slope, okay? So we're actually, I like to use this y minus y1 is equal to m times x minus x1, okay? I know already what x1 is. This is really x1. This is 3 right here. Okay, there it is. Alright, so let's see what we come up with. I need to find the slope. Actually, K prime at 3, but I'm going to find K prime at x first. Now remember, this is really, when you see a composite function like this, this is really a ploy, if you will, on the chain rule. So really, you take the derivative of the outer, the outer first. You leave the inner part alone, and then you take the derivative of the inner part, like that. Okay? Now, this equals, now since we're dealing with x equals 3, we're looking at f prime at g at 3 times g prime at x. It's kind of like saying, well, what if f at x were equal to sine of 2x? This is the f at g at x here. So you would take the derivative of sine, so f prime at x would be take the derivative of sine, which is cosine, and then not do anything here, times the derivative of 2x like this, which is really just 2. So this would be equal to 2 cosine of 2x. That's really what this is about here. Alright, just kind of keep that in mind. Alright, that's really like a composite function, and that's what you're dealing with. Okay, so now let's deal with this. F prime, leave the prime up there, don't forget that, of g at 3. Now I want to find g at 3. G at 3 is 6. G at 3 is 6. So g at 3 is 6 times g prime at 3. You're still putting 3 in place of the x here. I needed to put the 3 in here. So, alright, there we go. Alright, f prime at 6. So I'm looking at f prime at 6. That is 5. Alright, so 5 times g prime at 3 is 2. So 5 times 2 is 10. And really that's what you're doing. Okay. Again, this is probably, to me, in my eyes, this is probably one of the easier problems. So if you're a student, you should be able to breeze through this. Okay, if you're a teacher, this is something you can use to teach your students how to interpret this graph and know what kind of derivative you're up against. And that's what you do. Oh, we have not, that's just the slope. We have not gotten the rest of this. Okay, so we do know that the slope is 10. Now all we need is y1. Well, okay, I know that k at 3, let's erase this. Alright, I got my slope. That's what I found. I almost forgot to do the equation of the line, of all things. And that's good that we found the slope, but now we got to find the y1. Well, we're dealing with x being 3, so we're going to say k at 3, alright, is equal to f at g at 3. So that's really what we're looking at. Alright, so g at 3, so f at g at 3, so g at 3 is 6. Alright, 6. And f at 6 is 4. Alright, so now I have all the ingredients. This is y1 is 4. So now this is 4. Some authors will say, well, solve for y, add the 4 to both sides if you want, but I do believe you can leave it like this. So then we have y equals 10 times x minus 3 plus 4. Guys, if you leave it like this in the first place without bringing the 4 over, they're not going to count that incorrectly. Okay? You have an equation. Okay? And you don't have to multiply the 10 times x and 10 times 3 and collect terms. You don't have to do all that. Just leave it like this. Okay, that is part A. That is it right there. So you had to find your slope. You already knew your x1. You had to find your y1. Just simply plug that into that right there, okay? That's how you do that. And they're just testing your ability to interpret how to find y and how to find the slope. Alright, how to take this derivative here. Alright, so I'm just going to use this side here. I could use the other side, but I'd have to flip back and forth to look at the graph. So bear with me. I don't have the top technology that other people might have where they can pull stuff up immediately, but I'm liking this whiteboard. It does what I need. And all, if it can help you understand this, then this is alright. Alright, let's look at B part. Alright, well, h at x is equal to g at x over f at x. Now you got to remember to put the g in the numerator and the f in the denominator, otherwise you're going to get it upside down. Find h prime at 1, right? We're looking for h prime at 1. Okay, I like to do the derivative first, so let's put it over here. H prime at x. Now, okay, this is, what rule is this? Yeah, the quotient rule. Oh, I don't know if I'm going to have room up here because the quotient rule can be stretched out a little bit. Let's see. Maybe we'll have room. I might can start it down here. Okay. Alright, so h prime at x. Some people said low times the derivative of high minus high times the derivative of low over low squared. Okay. Yeah, I mean, any way that you can memorize that is good. Alright, so low d high minus high d low over low squared. Okay. That's one thing you can do. I always like to remember, if I bring up the f, I'm not going to take the derivative at the same time. I'm not going to make the same two moves with one part. So in other words, after I move the f up, I'm not going to turn around and take the derivative of f. Take the derivative of g. So I'm moving the f up like that, and now I take the derivative of g. Alright, minus sign always, not plus. Right, minus now high now times d low all over low and squared. Okay, like that. Alright, so really what we're looking at is h prime at 1. So really what I need to do is insert a 1 in all of these. Alright, that's what I'm going to do. So again, it's just testing your ability to interpret this up here and to find the derivative. Know what to do here. This is a quotient rule. Okay. F at 1, let's see what we have up here. Let's put it up here. Alright, so h prime at 1, alright, equals f at 1 is -6. Alright, g prime at 1. Now not g, but g prime at 1 is 8. Alright, minus sign. Now g at 1 is 2. Alright, f prime at 1 is 3. Alright, like that. Now over f at 1, so f at 1 is negative 6. Alright, don't make a rookie mistake and forget that parentheses there. Okay. Alright, F at 1 is negative 6. Alright, so what we have is negative 48 minus 6 over 36, don't we? Alright, so what we have here is adding these signs are alike, so the 8, 6, 14, 54, negative 54 over 36. 9 will go into both of them. Alright, so let's see. 6, well, we could have probably done 18. Alright, it's okay. 6 times 9 is 54, and 36 divided by 9 is 4. We can go one more, divide by 2. Yeah, I'll remember, 18 goes into this. Okay, so negative 3 over 2. Alright, like that. Okay, there it is. Low d high minus high d low over low squared. And that's basically all we had to find with that, right? Okay. Now the third one could be a little tricky. Okay, and I'm going to show you a little thing you can do. I had somebody show me this a long time ago, and I like it. It keeps me straight on these kinds of problems here. Okay, here we go. The thing is, it's not so much the antiderivative, it's what's inside here. So we're going from 1 to 3, and here is f double prime at x dx. It's not x, it's 2x, and that you have to be extremely careful with that. Now, one thing that we know is when we take the antiderivative of the second derivative, we get down to the first derivative, don't we? So we knock f double prime down to f prime. Took it again, we would just be down to f. But we're down to this. Now, well, let's see. We've got to let u be equal to 2x. Alright, now at this point, and I'm just going to go ahead and get du. Du is equal to 2 dx. Remember when we multiply by half? Oops. Times a half. 1/2 du is equal to this dx. So we know that we're going to need a 1/2 out in front here. But now I want to change this. Okay, I want to change this integration. The limits of integration is what we want to change. Because I have a 2x here. Alright, and so I can do this. Let's go back to u being equal to 2x. Always remember, plug in the numbers in place of x and let's get it down to u. It makes it a little easier. Okay, so u is 2 times 3, which is 6. So that changed to a 6 up here. Let's see that. And then u is equal to 2 times 1, which is 2. And then instead of using f double prime at 2x, now we kind of eliminated the 2x. We let u be 2x. So now f double prime at u, du. Okay, see that? Don't forget you do have 1/2 sitting out here. That's how you change the limits of integration. U is whatever U is, you can plug these numbers into X and change that, and that way now you can eliminate the 2 right here. Okay. Okay, so really, let's see what we've got now, because this is now equal to 1/2 times F prime at 6. Remember the rule of the first fundamental theorem or second fundamental theorem of the calculus. Alright, would be the minus. Alright, F prime now at 2. Okay, like that. Alright, F prime at 6. F prime at 6 is 4. So this is equal to, whoa, I need to erase some of this. Alright, bear with me while I do this. I appreciate everyone, believe me, I really do. Alright, so 1/2. 1/2 F prime at 6, we found that to be 4, didn't we? F prime at 2, F prime at 2 is -2. I do believe that's correct. F prime at 2 is -2. Alright, so equals 1/2. 4 plus 2 is 6. Alright, so half of 6 is 3. Like that. Okay. I do believe I got all of that correct. Just make sure that you understand that I'm thinking that is 3. I just, you know, been a while since I've looked at the final answers to these. Let me look that up real quickly. I'm going to pull that up. So bear with me. I'll be away from you just for a minute, just for a second. And I'm going to pull this up, but I do believe I have that. But that's the right idea anyway. So let me see. Give me about a couple of minutes here, maybe, if this will come up. Okay. Okay. Alright. And this is question number 6. Question number 6. Well, some reason or another, I got supposed to have gotten a 5 here instead of a 4. That would have been. That's why I thought the other answers are correct. Let's see. F prime at 6. F prime at 6 is not. F at 6 is 4. I knew something didn't look right. So this is 5. Yes. And then F prime at 2 is -2. So this is actually 7. And so when I got this answer, I got to thinking that's not exactly what I got from last time. One thing about it, I may be 63 years old, but I can still remember if something didn't look right. The rest of the problems that we did are correct. I did this correctly anyway. So please don't lose confidence in me, okay? Just KB, the math G just made a little mistake there. I was looking at F instead of F prime. Okay, should have paid closer attention to that. That's 5 minus -2. That is correct. So 7 times 1/2 is 7/2. Okay. Well, that's it. Okay. This idea here and learning how to do this, it takes a little time to learn that. Okay. But it's not difficult to learn. Okay. not too difficult. Anyway, this is KP the Math G. If you want to subscribe, you may. If you want to make a comment, you may. If you want to hit that like button, I always smile when I say that. That like button. I love that. Please do so. If not, that's okay. I hope you get something out of this. And I always say, it's not for my glory, it's for yours. It's for your benefit. So anyway, thank you so much for your time and your patience and your attention. This is KP the Math G signing off. Ladies and gentlemen, have a great, great day. All right.